Morning everyone, this is Deepshikha Dubey from Acropolis Indore. Welcomes you all once again in my lecture series. And my today's topic is we have to find particular integral with general method for higher order linear differential equation with constant coefficients. So we will proceed with the definition of linear differential equation. Here you can see on my screen the definition of linear differential equation says that a differential equation of the form dny by dxn plus p1 dn minus 1 by dxn minus 1 and so on is equal to q of x is called a linear differential equation of order n with constant coefficients where p1, p2 and pn they all are real constants. D is equal to d by dx, d square is equal to d2 by dx square. They all are differential operators, and equation number 1 can be written as function of d of y is equal to q of x, where function of d is equal to d to the power n plus p1 dn minus 1 plus p2 dn minus 2 and so on. Now the general solution of the above equation is given by y is equal to cf plus pi, or else we can write it y is equal to yc plus yp, where yc stands for complementary function and yp stands for particular integral. For finding complementary function, first we have to make an auxiliary equation. We will put d is equal to m, y is equal to 1 and right hand side equal to 0 in equation number 1. We will get an equation in terms of m, that is f of m is equal to 0. It is an algebraic equation, and after solving this equation we will have some roots, and we have already discussed in my previous lecture about different cases for finding complementary functions. So today we will discuss about general method for finding particular integral. We will start with the formula. You can see on my screen. So general method for finding particular integral says that if f of d of y is equal to q of x, where q of x is a function of x on right hand side of the given equation, and if f of d in the form of d minus a, so the formula is yp is equal to 1 upon d minus a, q of x is equal to e to the power ax integration e to the power minus ax q of x dx. Similarly, if f of d is equal to d plus a, then y of p is equal to 1 upon d plus a, q of x is equal to e to the power minus ax integration of e to the power ax q of x dx. And the necessary condition for general method is the function of d should be in the form of linear factors, like f of d must be as d minus m1, d minus m2, d minus m3 and so on. It depends upon the different roots. So we will further proceed for an example. Here is the example. Solve the differential equation d square plus 4 of y is equal to 10 to x. Now, solution of this equation is given by y equal to yc plus yp. This is total solution. First of all, we have to calculate complementary function, that is yc. As I have already mentioned in my previous lectures, we have to make an auxiliary equation. So we will put d is equal to m, y is equal to 1 and right hand side is equal to 0. In the given equation, we will get here m square plus 4 equal to 0. This is our auxiliary equation. After solving this equation, we will get m is equal to plus minus 2i. You can see that these are imaginary roots, and we will apply the case for imaginary roots. If it is in the form of alpha plus minus I beta, then complementary function must be e to the power alpha x c1 cos of beta x plus c2 sin of beta x, where alpha is equal to 0 and beta is equal to 2. So we will have our complementary function like this. This is alpha, this is beta. So we will write here e to the power 0x, which is equal to 1 c1 cos 2x plus c2 sin 2x. So this is the complementary function. Now we will proceed for particular integral. So you can see we will define particular integral as pi is equal to 1 upon f of d dot f of x is equal to 1 upon d square plus 4 dot tan 2x, which is a value of right hand side of the equation. So I have already mentioned that function of d must be into must return into linear factors. So we will write d square plus 4 as d minus 2i dot d plus 2i. So our equation will become 1 upon d minus 2i dot d plus 2i dot tan 2x. Now we have to break d minus 2i dot d plus 2i. So we will use the method of partial fraction, and here is the method. You can see we will write 1 upon d minus 2i dot d plus 2i as a upon d minus 2i plus b upon d plus 2i. After taking LCM, we will have the equation 1 is equal to a dot d plus 2i and b dot d minus 2i. Now put d is equal to 2i in equation number star. In equation number star, we will get 1 is equal to a dot 2i plus 2i, because 2i minus 2i will become 0 here. So the value of a is equal to 1 upon 4i. Similarly, if we put d is equal to minus 2i in equation number star, so we will get here 1 is equal to minus 4ib, because here minus 2i plus 2i will become 0. So the value of b is equal to minus 4 upon I. So my equation will become like, we will put the value of a here. So we will have 1 upon 4i, 1 upon d minus 2i. Now the value of b is minus 1 by 4i dot 1 upon d plus 2i. So we will write this equation as 1 upon 4i as common. So the equation is 1 by d minus 2i minus 1 upon d plus 2i. So we will write the equation as 1 by 4i dot d minus 2i minus 1 upon d plus 2i dot tan 2x. Now in my particular integral, there are two parts in this equation. First one is represent as 1 by d minus 2i tan 2x, and the another one represents as 1 by d plus 2i tan 2x. We will mention this equation as equation number 1. Now we will solve our first part in particular integral, which is given by 1 upon d minus 2i dot tan 2x. This is equal to e to the power 2ix integration of e to the power minus 2ix tan 2x dx by the formula of general method. As I have already mentioned, by the formula of general method, this is equal to 1 upon d minus a. So here the value of a is equal to 2i, so that we can return as e to the power ax, that is 2ix integration e to the power minus ax, that is 2ix dot f of x, that is tan 2x dx. Now you know that e to the power minus I theta can be written as cos theta minus I sin theta. Here theta represents 2x, so we can write e to the power minus 2ix as cos 2x minus I sin 2x dot tan 2x. Now we will multiply tan 2x with these expression cos 2x minus I sin 2x. So cos 2x dot tan 2x will become dot tan 2x is written as sin 2x by cos 2x, and if we cancel cos 2x by cos 2x, we will have here sin 2x. Similarly, if we multiply sin 2x with tan 2x, we will here sin square 2x by cos 2x dx. Now, sin square 2x will be written as 1 minus cos square 2x. So again, we have, if we write 1 by cos 2x, we will get here sec 2x, and if we will write cos square 2x by cos 2x, we will have here cos 2x, and if we multiply minus in this bracket, so we will get here minus 1 by cos 2x as minus sec 2x, and minus minus plus, so it will become cos 2x dx. So e to the power 2ix, after integrating this function sin 2x, we will get minus 1 by 2 cos 2x. The integration of sec 2x will become log of sec 2x plus tan 2x by 2, and the integration of cos 2x will become sin 2x by 2. So this is the solution of part 1. Now, if in equation number 2, this is the equation number 2, solution of part 1. If we replace I by minus I, we will get the solution of part 2. That is e to the power minus 2ix minus 1 by 2 e to the power 2ix. As you can see that in this equation here e to the power minus 2ix, but we replace I by minus I, so we will get e to the power 2ix. Similarly, here I, if we plot minus I, so minus minus become plus, so we will get plus I by 2 log of sec 2x plus tan 2x. This is the result of part 2. Now, we will plot these two results in equation number 1. So, we will get here 1 upon 4i e to the power 2ix in bracket minus 1 by 2 e to the power minus 2ix minus I by 2 log of sec 2x plus tan 2x. Similarly, this is part 2 with the multiplication of minus 1 by 4i. Now, we have to solve this expression, and we will take minus I by 2 e to the power 2ix log of sec 2x plus tan 2x plus 1 by 2 and minus 1 by 2, they both are cancelled, and minus I by 2 e to the power minus 2ix log of sec 2x plus tan 2x. After multiplying e to the power 2ix in this whole expression, we will get this expression. Now, we will have 1 upon 4i in bracket minus I e to the power 2ix plus e to the power minus 2ix by 2 log of sec 2x plus tan 2x, as we can take this term log sec 2x plus tan 2x as common term. So, we will have here minus I e to the power 2ix plus e to the power minus 2ix by 2, because we have minus I also as a common term. Now, you know that there is another formula for e to the power I theta plus e to the power minus I theta by 2 is equal to cos of 2 theta. So, we can replace here theta by cos of theta. This is equal to cos theta. So, we can replace theta by 2x here. So, e to the power 2ix plus e to the power minus 2ix by 2 can be written as cos 2x. So, we will have here cos 2x log of sec 2x plus tan 2x. We will cancel I by minus I. So, we will have minus 1 by 4 cos of 2x log of sec 2x plus tan 2x. This is the particular integral, and the complete solution of the equation is given by y is equal to cf plus pi. So y equal to c1 cos 2x plus c2 sin 2x minus 1 by 4 in bracket cos 2x log of sec 2x plus tan 2x. So I hope you all understand the general method for finding particular integral. Now I am suggesting you some books, some reference books for understand the concept. Here are the books. So thank you so much everyone. Have a good day.